All right, so for page 88, you're going to make a pocket, and this worksheet is going to go in this pocket. We're going to graph an example of a logarithmic that has been transformed. And so on this one, we're going to do number 3 together. And so if you will, we're going to start by reading the directions. And so then we'll do number 3. On number 3, start with the parent function, which in this case is going to be the log with the base and the x part without the negative on there. So log base 3 of x is going to be our parent function. If you remember, we'll take out this negative here to be able to see the different transformations. Unless you don't want to take out the negative, you don't have to, but just keep in mind that that negative is going to affect your transformation slightly. So this negative on the inside with the log function is going to make it reflect over the y-axis. So we have a reflection over y. And then we have left 4. And then the minus 2 on the outside we know is going to make it go down 2. So when you're setting up your table for your parent function, you'll have log base 3 of x for your y values. In your x, you want to be mindful of the numbers that you plug in. Obviously, you can't plug in negative numbers. The domain of a logarithmic is x is bigger than 0, so you have to choose numbers that are bigger than 0. The reason being is because let's say I do log base 3 of negative 3, for example. Well, what that's asking is it's asking you 3 to what power of y will give you negative 3. So if you use a positive value of y, you'll get some number that is going to be a whole number if you allow y to be bigger than 1. If you allow y to be 0, you'll get 1. But if you allow y to be a negative number, you'll actually get the reciprocal. There is absolutely no power at all that will give you a negative number when you raise 3 to that exponent. So as a result, this wouldn't make any sense. So first of all, don't put like things in like negative 2, negative 1, 0, even 0. You wouldn't be able to get 0 whenever you raise 3 to some exponent of y. You still wouldn't be able to get 0. So that means you want to be strategic in the numbers that you choose. For example, you definitely want to include the number 3 because that's an easy one. That's really asking you log base 3 of 3 equals y, which is saying 3 to what power y gives you 3. Well, that's easy. That's just 1. You definitely want to include the number 1 in here as well, because if I change this x value to a 1, 3 to what y power gives me 1, well, that's 0. So that's an easy one as well. And then other numbers you'll want to include are like, for example, 1/3. Because when you do 3 to what y power gives you 1/3, because this is a reciprocal now of 3, you want to have negative exponents here, and so that value is going to be negative 1. And then you can choose things like, for example, 9, and that would give you 2, and then you could choose 1/9, and that would give you negative 2. So values like that would work out. You could use numbers like 2, 4, 5, and so forth, but if you're more strategic about it and use your base as a guide, you'll end up with very nice numbers to work with. Now, to make these transformations happen, in order to make it go left 4, we're going to do x minus 4. In order to make it reflect over the y value, we're going to take our x's and make them negative. So we'll have negative x minus 4. And then to make it go down 2, we'll end up doing y minus 2. So very easy peasy, same thing that we learned in chapter 1. The only thing that was a little bit more, we had to be a little bit more careful with was making our parent function values for our x's and y's. But besides that, everything else that we learned in chapter 1 is going to work out here. So we'll do negative 1 minus 4 to be negative 5. We'll do negative 3 minus 4 to make that negative 7. And then negative 1/3 minus 4 is going to be negative 4 1/3. You can make that an improper fraction if you want to. I'm going to leave it as a mixed number so that I can easily graph it. And then 0 minus 2 is negative 2, 1 minus 2 is negative 1, and negative 1 minus 2 is negative 3. So now I'm going to graph these. Negative 5, negative 2, negative 7, negative 1, negative 4 1/3, comma, negative 3. And so now my graph looks something kind of like this. Keep in mind my parent function has a vertical asymptote at the y-axis. So it's going to be at x equals 0 is it's going to be its vertical asymptote. And then it has an x-intercept at 1, 0. So it's going to be a graph that looks something kind of like this. So you do see that reflection over the y-axis, that moving it left 4 and then down 2. It's kind of hard to see, but it does have that down 2. The last thing I want to make sure to include on this new transform function is its vertical asymptote. Since the original vertical asymptote was here as x equals 0 and this graph got moved left 4, the left and right transformations are going to move your vertical asymptote as well. So now my new vertical asymptote will be at x equals negative 4. So we have a vertical asymptote at x equals negative 4. That's one of the pieces of information that I wanted to know. We have our domain to be the values of x such that x is less than negative 4. I didn't put my equal to symbol here because of that vertical asymptote. And my range is going to simply be all real numbers. Okay, and that's it for this example.